Friends, Naji here. Welcome to my YouTube channel. So we are continuing our discussion with Apache Spark, and in this video we will be discussing on RDD, that is Resilient Distributed Dataset. So what are RDD? So this is a fundamental data structure and which was there with the initial version of Spark itself. Okay. And it is distributed data abstraction, which means if you have a data structure and it will be logically divide that into different partitions, and each partition may be saved into different nodes. And one good thing is that we will able to access them separately, or we can execute them parallelly. Okay, so that is what we mean by the distributed. So here we can see this is a data set, or maybe consider it as a list of data, and which is partitioned to 3, and each partitioned data is saved into different nodes. Then it is resilient and immutable. So what is mean by resilient? So which means its ability to create at any point of execution of a cycle. So we will able to recreate the RDD at any point of time. So this is fault tolerance. If any problem is happen, we will able to recreate the RDD. And immutable, which means if you apply any transformation to the RDD, okay, it will not change the old one. It is always creating a new one. So that is what mean by the immutable. So this term is very familiar, right? Immutable. So we used to say that we have a immutable data structures in Python and also in different languages. So here it is RDD is a immutable. Okay. So here we can see that there are 3 RDDs are there. So we are applying the different transformations to these RDD. Okay. So if you are creating, we can see a yellow RDD, a base one, then we are doing some transformations and we are creating a new RDD, RDD2. Okay. So it is actually not modifying the first one. So whenever something is happened, we will always able to recreate the first one. Okay, so that is the meaning of RDD and also the resilient and the immutable. Here we discussed about a term that is called transformation, and there is also another term or another term that we call the actions, transformations and actions, that is also come with the RDD. So that is a topic that we can discuss more in our coming videos, but in very short we can say that transformation is a function. Okay, maybe we can say that it's a lambda functions, map functions, all those things we can say it as a transformation functions. Then the actions means we can call it as a maybe some functions that we execute, like for example count. So consider a list. So in the list we can calculate the length, top 5 rows or 5 data of that length, that list. Those things are called the action methods. Okay. So don't worry, we can discuss more in our future videos. Then it's a compile time safe, which is very easy for the developers, because they don't need to wait until something happen during that runtime, right? So they will able to figure out the issues at the earliest in the compile time itself, and we will able to work with the structured and the unstructured data, and it is lazy in nature. Okay. So which means consider we have a RDD, and here we are applying 3 transformations and we have applying 1 action. Okay. So what happens? So whenever we do these transformations, it is not really executing these transformations. Okay, which is just saving the transformation information. Then whenever we call this action method, then only it will start executing. So that is what mean by the lazy. Okay. So for example, consider if you have a list of data of employees. So first transformation maybe we'll be filtering it by country, then next time we will be filtering it by age, and maybe we are filtering it by what do you call the salary. Then finally we need to get the number of employees by applying all this transformation. Okay. So only when we call get me the employee count, then only we will be executing all these transformations. So that is what mean by the lazy. So that is also a familiar term, right? Lazy loading, all those things we know. Yep. Then why use RDD? Okay. So it is actually provide us a control, and it also provides the flexibility. It's a low level API. Okay, since it's a low level API, we will have a lot of controls. Okay, and it is a type safe that we already discussed. And for the developers, developers are telling how to do the things. Okay, so that is how it gives the more control. Okay, so it is not the since it's a low level API, we have to tell each and everything how to do this, how to do this. So that is a kind of a control that we are getting. And when to use RDD, that is also a question. It's a low level API and we have a full control. So if you guys are allowed to have that power, then you can use that. Then if you are dealing with unstructured data like the streaming of video streaming, all those things, then we can use the RDD. Then if you have a lot of lambda functions, okay, then also we can use the RDD. And what's the problem with RDD? Okay, so one problem is not optimized by Spark. So we mentioned that this actually providing a low level APIs and developers are saying how to do this, right? So consider if the developers are not writing a good code. Okay, so they are doing something wrong. Okay, then Spark will execute exactly what the developer said. Okay, does not have any kind of a optimization power there. Okay, so we have to be careful. The developer is not good at writing good code, then we will have a problem. Then slow for non-JVM language, select Python. And if you are not, in your project, if this performance difference is fine, then you can use that. Otherwise, that is a problem. Okay, so that is all about the theory part. Now we can do some hands-on. So here I have opened a Visual Studio Code and a notebook is opened. Here we can see a PySpark is installed. So we can do a pip install PySpark, you can directly do. Then when we start a PySpark, first we need to create a Spark session. Okay, for that what we can do, we can import that from PySpark.sql and we can import the Spark session. So once we have the Spark session, we need to build that. Okay, for that there is a code that we can use. I can use the Spark session dot, I can build it, I can call it a builder, and here I can set a app name if needed. I can say that it's a RDD intro. So spelling is not correct, RDD intro. Then I can set master. Okay, so here I am using the local as my master, otherwise I can give the cloud information. Now I can create. For that I can use get or create method. Okay, so this will be executed, but it's giving some error. Okay, so let me check that Java gateway process before sending spot number. Okay, so it's unable to execute the Java runtime, so I need to install the Java, and this is the first time I am using this in my MacBook, so I have to do that. Okay, so I have installed the Java in my MacBook, and now it's working fine. So we just created the Spark session. Okay, now what we are going to do, we are going to create a data. So for that I can write range, and I am creating a data between 0 to 100. Now I can see the type of the data, it will be a range type. Okay. Now we need to convert this data into RDD. For that they are providing a method. We can use the Spark context. We can say that Spark context dot parallelize method. We can use parallelize data, this will create the RDD data structure. So we can just execute this, and let me type the data. Okay, so sorry, not data, RDD, small letter RDD, you can type it now. RDD, now execute it. See, now we are creating a RDD of we are creating a pipeline of RDD. Okay, now we can see, so what we discussed, we said that okay, this is creating a partitions. Now we can see how many partitions are there. For that, what we can use, there is a built-in method is there, RDD dot get number of partitions. So let me see. So we have only one partition. Okay, so maybe I can try, I can pass the partition numbers here. So let me check that. Maybe I can pass this one like number of slices. I can mention here, I can say number of slices 3. Now here we can try get number of partitions. We can see how many. See, here we can see there are 3 partitions. So because since I have mentioned here number of 3, so it's created 3 partitions. Okay, now we need to fetch and we need to see these partitions, right? We created the partition, that is fine. Now we need to see that. Okay, how to get those data? So I can get the partition data. For that, what we will be using, we are calling RDD. There is a method called glom. Then I can call dot collect. So this will give us the partition data. Okay, maybe let me try with partition data. No, length is not there. Here we can see 3. Now we can print the data. For that, I can use a for loop, I can use a IDX. Now I can use a data in. Okay, I can use the enumerate function, then partition data. Here let me print those data. Print. Here partition number is IDX. Sorry about the spelling mistake. Then data I can mention as data. Let me execute this. See, we can see here we can see the partition data. We have created the 3 partitions and we can see how the partition is done. Okay, so that is about the coding part. So this is just an introduction. So we understood how to create a Spark session and how to create a RDD and how to get a number of partitions. All those things we have discussed. Okay, so let me go back to the slide. So this is our slide. Okay, so we have done the coding part. Now okay, so thanks, that is all about in this video. So please do like and subscribe. In our coming videos we can discuss more about other data structures and we can discuss about transformations and actions, all those things. Okay, so that's it. Bye bye.